All right, so Tameika Reed, founder of Women in Linux. Today, my topic is deploying your app securely to the cloud. But I want to talk about some things that when we're trying to pick a cloud, some things that we need to be aware of. Also, I want to talk about from the perspective of, who and what we should be looking out for when we're saying, hey, we want to choose between an on-prem cloud, or if we want to choose something in the cloud, or is it a hybrid cloud, or is it a multi-cloud strategy, or even a migration to the cloud, where you may leave some stuff on-prem and maybe have some workloads inside the cloud. So let's get into this. All right. So one of the things that often come up is like, which cloud should I choose? And why should I choose this particular cloud? My first instinct, and it will always be my first instinct, is who is on your team, and do those people have the proper training, and do they understand what it takes for us to pick this particular cloud? Oftentimes, you'll find that people are doing the lift and shift. So what does that mean? Meaning taking your VMs that are on-prem or in your data centers, and then lifting them directly over to the cloud. AWS has a company that they bought called Cloud Endure, where they're doing a lift and shift directly to the cloud. Another one is when you're talking about you want to take your cloud, is what does it mean to be cloud native? You just heard Kelsey talk about being cloud native. There are several books out there on what it means to be cloud native. My thought process is when you're choosing the cloud, look at what you have in your as far as your workload, whether you have a huge reliance on data and doing machine learning or business intelligence, or you need quick workloads. So for example, there may be a particular GPU that's only offered inside of Google Cloud. So you would choose Google Cloud because you need that particular GPU in order to do your work. Or you may choose to go another route and say, okay, well, and this could get into one of the big things that we're going to talk about is cost. Or, hey, we don't really need that GPU, and then we'll use here. The other one that's on the screen is security. So when we talk about cloud security, we're talking about, for me, I look at it as the gamut of everything. And when I say the gamut of everything, I mean the particular AMI that you choose inside of the cloud. Whether you, and I don't know if anybody remember this, but there was an actual AMI sitting out in Amazon's cloud, and that AMI had a miner on it, and it had been sitting out there for 5 years, and thousands of people have used this miner. So basically, anytime you spun up this particular instance, it's just going to start mining Bitcoin for you. And people didn't even know that it was doing it. And it was out there for 5 years. So now you have to think about, well, okay, can I really trust what the cloud is giving me? There is a shared responsibility model, but I take it even one step further in saying, okay, I have the ownership on myself to make sure that once I use this particular AMI, or I use this particular Docker container, that it meets the standards of the company. That company standards could be NIST standards, it could be PCI standards, it could be SOC standards. So you just need to make sure that you're having these concerns ahead of time. Always think cloud first. Well, not cloud, I should say security first. A lot of people say think speed first, but the problem with thinking with speed first is you forget security. And then what ends up happening is you have to go back and try to implement security around that speed. And then people get lost in the sauce. And then it's a tragedy waiting to happen. The other part of this is when we're talking about security concerns is scalability, right? So some people will choose the the reason why they go to the cloud is because they want to be able to scale. But what does that mean? Scalability could come back to the original thing that I said before, is training. When you're starting making new services, when you're starting making new, when you're starting to bring on new tools, when you're starting to bring in new applications, when you're trying to just scale your infrastructure itself at a rate without having some type of understanding of what that, I guess, the main goal, the main process is. In other words, a template of with security wrapped around it, you can always get out of hand. And next thing you know, you having vulnerabilities all over the place. Things are not patched. Containers are coming from everywhere. You know, setting that tone and setting those fixes is very important. All right, next one. All right, why should you care? Okay, so why should you care is, I gave you the one example of security with the vulnerabilities. The other example is, hey, what happens when we get an audit? Say a customer comes in and says, hey, I've been using your platform, and that customer can be internal. I've been using this platform and we've been using these things and we got hacked. So you have no idea, one, where that particular container came from, where the hack came from, where the instance came from, the AMI. You have no credit. You have no way to audit yourself, right? So you need to stay in a constant flux, or I guess a constant goal to have your own auditing yourself. The next one is, we all heard about the SolarWinds, is also the actual code that you're using. I hear people all the time, yeah, I just copied this GitHub repo and it should be okay, you know, but again, you don't know, right? You don't know if somebody wrote a backdoor unless you went through all the code. You just know you got something to work. So the other one is being able to scan your code, right? Being able to make sure that you're not bringing in any vulnerabilities. The more that you can cut down on the vulnerabilities, the better. And last but not least, why you should care is money. Deadlines, money, migrating to the cloud, training, money, how many people on the team can do the work, money. You can say, hey, we don't really have solid engineers. We need to take some time and go hire some engineers that really have the experience that we're looking for. Well, that's money, because if you're looking for a senior person, they may want, you know, a cut. Of course, they're cut, but not only that, they want, you know, a sense of guiding the ship. So what does that look like, especially if they're coming in and the people are what some people consider newbies, or they don't have that senior level experience or that architect experience? That's money for that. The other thing is, when you're talking about which cloud you should pick, is also and why you should be concerned, is also the tool sets surrounding it. Like when you start getting into DevSecOps, when you start looking at, you know, okay, we want to break down the silos of the development, the silos of security, and the silos of operation, move cohesively as a team to get this migration done. So now you have to look at, well, it's time around that, and that time is relearning and rethinking how to make that work and how to train people on this methodology, and then also move people to move it cohesively to get the job done. So those are nuances that I say when you're choosing not just the cloud, these are nuances that we are also talking about when we're concerned about, well, which cloud you should pick, what kind of security concerns you should have, and so forth. And I got some more information that I wanted to actually bring over when we're talking about picking out the cloud. So there's different levels. I don't know if you all are aware of this when we're talking about cloud and cloud security. So here is, this is from DISA. And so it talks about different cybersecurity standards. There was a conference earlier this week talking about the SASE model, and I'll bring that up too. But I just wanted you to be aware of this as you go forward to talk about, how do you pick your cloud, and also wrapping security around picking your cloud and what provides you the best model. So in some instances, you have different IL levels. Let me look at it on here, see if we can find that here. So there's IL level 2, IL level 3, IL level 4, 5, and 6. And those are different levels when it comes to different classifications. So here's the classifications right here. So when you're looking in not just in government, but those who are have collecting PII, think about all your health care. Think about all your not just your health care, but think about your all the your Social Security numbers, your checking account, your banking account, your whole life insurance, your real estate, and so forth. These are things that you need to think about as well too as you migrate to the cloud. Do you take everything that's on-prem and put it in the cloud? Do you leave that behind? Do you set up some type of hybrid model? Do you, another thing to think about too, as we talk about this migration to the cloud or which cloud to pick, is when you have your data, when you're ingesting this data and you need to move data across availability zones, we need to start thinking about the cost of that, right? So you may have something in one availability zone and then something else in another availability zone because you got some separation, but now you need to transfer that data over. So now you're incurring cost inside your own network. So there's things to think about as we architect the cloud as well too. And I'll drop this a link into the chat. I see you all asking about this. I think it's just a great way to look at some stuff. Another piece that I want to bring up as well too is different clouds have different classifications. So here's one here. So this one was Microsoft talking about their being able to reach their IL level. I think this may be IL level 5 and IL level 6 is top secret. However, what that means is those workloads, you all heard about the SolarWinds hack, being able to get all the way down to the nuclear, our nuclear defenses, right? So now you have to think about, well, that code came in, the code was scanned and then implemented across the network. And this is not just, the US that's using it, it's across multiple countries and multiple industries, right? And so now you have to think about, okay, well, who's watching the watcher, right? Because that's what this boiled down to, who is watching the watcher. So the reason why I brought up Microsoft, because I know everybody remembered the big debacle with Amazon and Microsoft, where they were bidding on the contract, and the contract was for 11 billion, or was it 10 billion? 10 or 11 billion. I could take one of those billions. But in terms of what level of secrecy the data exists on. So just things I want you to be aware of when you're picking the cloud and you're working with customers and you want to help secure their data. You want to create applications. You want to be mindful of security throughout the process, not at the end of the process, not in the middle, but throughout the entire process. Where are the containers coming from? Are you making these containers and so forth? So last but not least in my presentation is this here. So this is what a security pipeline, this is really scaled down. I want to keep it very minimal. This right here hey, I'm now gonna take something that I'm going to create, maybe a Docker file, or maybe I'm going to create an instance out in AWS, or maybe I'm going to create a container, or maybe I'm going to create something over in GCP, and you can just easily add Azure to this, or DigitalOcean, or whatever cloud you want to here to this. So basically what I'm going to do is I'm going to create some code, right? And I'm going to check that code into GitLab. And GitLab is going to go off and create, well, I create the runner. I'll show you that in a minute. But GitLab itself has its own set of runners. Well, they have an obligation and they have a security posture that says that the runners that you're using on our platform are secure. They've passed these set of standards. You can do your own scanning on that if you want to, or you could just trust us. So now the question is, do you just trust them, right? So the next part of this is we have a tool, and it's from Hashi. Hashi has a tool out there called Packer. It's really a combination here of Terraform and Packer. But what I can do with Packer, and let me pull that up so you can have an idea of what Packer has the ability to do. So you're not like, oh, what is Packer? But it'll give you an idea of what Packer can do itself. So Packer is, I use that as my automation tool to create various objects. So when I say various objects, I can use Packer to create instances out in Azure. I can create instances out in AWS. I can create instances or VMs, OVAs on VMware. I can actually do this inside of Amazon, and I'm going to pull that up so you can see it. Google Cloud, Docker containers, and also DigitalOcean. So you can look at their providers that they have and get a sense of it. So they have an intro over here about just different use cases. So let's take a look at their use cases. So their use cases is being able to have continuous delivery. Well, in my mind and in my head, I'm always looking like, where did this container come from? Has it been scanned? Do we know that it doesn't have any vulnerabilities? Where did this AMI come from inside of AWS or inside of Google Cloud, this instance, this compute engine? Do we know? Can we trust it? Those type of things. So you want to at least scan that first before you commit your code to it or you start using it. And so the way if we look back at this diagram here, is we can use Packer to create our instance here. We can use Packer to create our container. We can use Packer to create our compute engine or instance inside of GCP. But there's other things we can do with Packer too, right? We can then have Packer push out our end results, whether it be a container to a container registry. We can push it out to Google Cloud, where we have images in Google Cloud. So let me show you that as well too when I'm talking about that, so you're not like, oh, what is she talking about? Let's go right to it. I'm pulling up Google Cloud right now. Going to the console. Let's pull this over. All right. So inside of Google Cloud, if you click on the menu up here at the top, as soon as it gets refreshed here, I know you can do it. All right. So if you go down to compute engine, I gotta move my screen over here so I can see. All right. So we go down here to compute engine. You'll see that you have several different instances. You have images that you can pick and choose from. So if I click on, I want to create another one here. So let's go here and create another one. And I'll show you exactly what I'm referring to. So when we get down here, we're saying, hey, we want to use this image right here that is a Debian-based image. But do I know where that actually came from? Do I trust it? I can change, and it will give me a whole listing of different images that I can pick and choose from. So based upon my operating system, say I want to use Red Hat. So then I click on Red Hat, and then I do a drop down menu. They'll offer me RHEL 7 and RHEL 8. But what you also see here is, oh, it's too small. Oh my God, hold on. How about that? What you also see here is I have custom images that I can pick and choose from. So if I click on this custom image would be something that I would have created. You see, I don't have any more images. It's learn about images. So I can go in and create my own custom image that has anything that I want in there, or in terms of like, hey, I want to make sure this has the latest patches. I want to make sure this has this set of tools. I want to make sure that it has all these things that I put in there, that I make sure that it's already patched. They pass the security standards and the security posture that we have set as a team and as a company. And then I place that image out here in Google Cloud. The same thing can be done. And this is what's really cool about this, is that same type of pipeline that I showed you. You can use that pipeline to deploy that same type of image, or with the same security standards, into any of those clouds or any type of VMware, so forth, for platform, because you control where that goes. So now let's look at the code. All right. So we're going to start at the top, and then we're going to go into, we have to do a live coding session because you know what? It's failing on me. But that's okay. We're going to get through this. All right. So let me know if this is big enough. I need to change the background. I probably need to change the background. Let me look and see how can I change that background. And let me drop this link in there too. Hold on, let me make it bigger. That big. It's super huge on me. And you gotta forgive me. I'm looking at a 49-inch screen when I'm doing this. So forgive me. All right, so all right, so here I'll walk you through this. And I need to change this color scheme, but I forget how to change this background on here. I think I gotta go in my settings. I'll look at that in a minute. But right now you should be able to see this. So right here, this image right here, this right here is actually a container. So I have a project out here, TNR Will, TNR Will, and this container, I built that container. So let me see if I can pull up my actual command line. Hold on, pulling it over. All right, so let me make this a little bigger. All right, so let me clear my screen here. Is this big enough for you all? Let me know. Let's see if I can make the font bigger. All right, clear. All right, cool. All right, so if I do a Docker images, I have a whole slew of images. It's gonna pull back. Oh yeah. Thank you for verifying the app. Yeah, I forgot. I turned it off. It was killing my computer earlier. Hold on. So basically what I'm doing is I'm going through my list of Docker stuff, Docker images that I have. Let me get my application turned back on, and then we'll go from there. But basically, with my Docker images that I have, I actually download, say, something from GitHub, or I can use Packer to create my own Docker image. So let me turn Docker back on here. Opening up the app right now. And then so when I grab that image, I can do a scan. So while this is coming up, let me show you how you can actually do this too. It's called OSCAP. And it's called OSCAP for Docker. OSCAP security for Docker, and I'll bring this over so you can see that. All right, so here is one OSCAP right here. All right, so here they have Rail 8 out, but you can go directly to this site right here. I dropped this in the chat, and you can go for Ubuntu as well too. They have one for Ubuntu as well. But anyway, basically, you're going to basically go through and set up your scan. You want to scan your Docker container to make sure that it meets the compliance that you want to have set for it. And you can also, and here it is, install OSCAP Docker, and then it goes through and gives you a result of like any CVEs. I'm not sure if everyone is familiar with CVEs, but there is a CVE database. So CVE database. Let's do CVE security. And this is common for all operating systems too. It's a good site to actually like keep up with daily. If you ever want to know what vulnerabilities are out there or what issues are out there, this is a good site for all the operating systems, not just Linux. So it lets you know what CVEs came out for that day or came out for that past month, what issues that they have. All right, let's see if Docker is up here and check out Docker images. If not, we could still skip this and go somewhere else. Have a demo. Okay, so here's my list of Docker images that I have on here. As you can see, I have different versions of these, and the reason why I have different versions of these is because I play around with them. I actually take the time to go through and prune them, make sure there's no vulnerabilities on them, and then I resave them and so forth. So just an idea of what you can do there. All right, so now let's get back to our GitHub repo. I should say GitLab, not GitHub. All right. And this is still big enough, correct? All right, so here you go. All right, so I showed you where I actually have that running on my system. I actually take that and I push that out to GitLab. GitLab itself has its own Docker container registry, so you can hold and house your containers inside your own registry. You don't have to actually push it out somewhere else, but you just need to make sure you scan. And so what we're going to do here is we're going to deploy a bare metal machine out to AWS. This bare metal machine that we're deploying out to AWS is going to be set up for us to do several things. And one of those things is, and you can see here I'm using Terraform to build this out, and I'll show you that code too. One of the things that we want to do is we want to grab an ISO from my S3 bucket. We're going to use Packer, and Packer is going to take that and push that down to push the ISO down to the actual system. And then once we use Packer is going to then generate us an OVA. We can generate a compute engine, and we can generate an instance, then convert that instance into an AMI inside of AWS. And what you see here is I actually have a stage here where we're sticking this actual content. So any questions so far before I move on and do some go into the actual project a little bit more? All right, so here we go. We're going into files. And what you have inside of GitLab is your GitLab YAML file. I showed you that. That sets up these different stages right here. So if we go back over here to pipelines, you can see where it failed. I'll show it to you where it failed. We have the pipelines that actually run here and here and here. And so those different stages get ran. So today, unfortunately, when I was running my pipelines, it was taking 22 minutes just to get started. So what I had to do is, and this is something that all developers can do, even with GitLab and GitLab Actions, is create your own instance. So what I did was I created my own runner. And I put that runner outside inside of AWS in the VPC that I wanted to work in. And then once I created this instance, registered that runner then comes back over here to AWS. If you come back over here to GitLab, and let's go into settings. Where are my settings at? Oh, here we go, down here. And we need to go into CI/CD. Hold on. That's pipelines. CI/CD here. And if you click on runner, I registered the runner. So you come here, you get you have to install the RPM for GitLab runners. They have that out there. You register this particular runner back with GitLab, and now I have my runner with some tags that I have associated with AWS. So now let's go over here. We're gonna do some changes real quick. I think I got 15 minutes. I'm looking on time, because I gotta make sure I leave room for questions as well. So
Tameika, you have about 20 minutes left, so yeah, you can talk for probably about 7-8 more minutes, and then we can take some questions.
Okay, cool. All right, cool. So we're gonna do this. I want to come over here now because I want to show the tags, where it gets tagged at how you know, how do you know that you're actually using that runner? That right there, that tag right there. Blow that up. That tag right there, tags AWS, that lets me know that when I push this code up, it's actually hitting that particular runner that's in AWS that's gonna go out and do whatever I tell it to do. So the way to look at this is that Docker container that gets downloaded becomes you. So anything you want it to do, anything that you do, you need to make sure that runner itself can do, because it's going to run from that Docker container. So basically, that Docker container becomes you. All right. So now let's do this. All right. So make this a little bigger, and let's clear. All right. So I'm in my directory. If I do it ls-a, I'll have my gitlab.ci.yml file. So let's VI that file. I'm old school. I'm not using any editors. Sorry. So you can see there where I have everything, and come down here. Here's my stages. So I know for a fact that it's been failing on me on certain stages, but I want to show you some stuff, not necessarily with Terraform, but what actually is going to take place. So inside this code here, we have Terraform is going to build my initial machine, and that machine has to have the ability to do virtualization. So that's why I chose a bare metal machine. And then on top of that, I then impose and install everything that I need for it to run, Packer and whatever else I want. And so now here, this is where I get everything staged at. I set my machine up, and then I come down here and I start running and creating my AMI. So what we're going to do here, because I know this has been failing on me, I'm trying to figure out why it's failing. Let's do this here. I know Ansible is installed, but let's just double check. Let's just do Ansible -- help. It should render back. All right, so now let's pull up AWS over here. Let's go to my dashboard. Oh, yay. Log me out, why don't you? In the middle of a demo. Phone time. All right, let me get logged back in. Got to do my authentication. 2-form factor here. Hold on. In the middle of a demo. Gotta love this. It's a different one. Switched on me. All right. We should be back. Never fails. Thank you, AWS, signing me out. All right, so you can see I already had 2 instances running here. One is my runner. The other one is, and the other one is this server that I built. So now I'm going to check in my code. Oh, that is the machine. That's the runner. Wrong machine. Here you go, right here. Let's go over to here. All right, so git add, git commit, make changes, nothing fancy here. And then let's do a git push. And then we're going to add the push. And now we need to go back over here to GitLab. I need to minimize this because I need my little side little menu to come back. And we'll go in here and pipelines. All right, so it's running now. And right now it's running on my actual runner that I have out here. I didn't make any changes to my machine. And the reason why I didn't do that is because it takes about 20 minutes for a bare metal machine to come up. As you can see, it's a C5 metal. It takes about 20 minutes for that to come up inside of AWS. So I didn't change anything on that. So therefore, that's going to skip that step. And now it's going to fail on the next one. And that's the part that I was trying to figure out why it was failing on. Nevertheless, we can still log into the machine and we can still see how Packer works. All right, so see, move there, fails. It's telling me about a pattern, whatever that is. I looked at it, but that's okay. Because why? Because the machine is up. And now we can log in onto the machine. And let's do that. All right, so on this machine, we're going to SSH, and that probably needs to be bigger because it looks small to me. All right, so SSH. I know what that's at. Is this one? Yeah. And then we're going to do EC2 user. Okay. At this IP address. All right. All right, so this is the machine that was up, and if I change, stuff, I'll get that machine back. That's what's cool about the security pipeline. You can always get the things back because it's already automated. All right, so let's clear this out. So what we wanted was this an ISO on this machine. So let me see. I don't think this is on here, but yep, not found. No problem. So what we want to do is have Packer installed. So let's go over here to Hashy, and let's grab Packer real quick. and download that. All right, here, copy and do a wget of this. Hold on, let's go to downloads and let's get the right one. Hold on. Copy link address. All right, so now you do a wget of Packer. Comes in a zip file. Oh, thank you, Amazon. You don't have that installed by default. All right, cool. Done. Now let's get Packer and download it. Boom, done. All right, now the next thing we need to do, I usually like this, the way Hashi documentation works, they like to install it in user local bin. So let's do an ls on that. So I don't know if zip is on here, but we're gonna find out real quick. Yep, got you. So yum install, unzip, -y. All right, done. Now unzip that, thank you. Now what you do is you have to move this over to user local bin. So let's move Packer over to user local bin. So now when I type Packer -- help, boom, done. All right, so now we got Packer up here and done and installed. So now I also have a file that's sitting out on my repository. We're gonna move quick. Don't shoot the messenger. We're just moving quick. Hold on. Let's get this. We're gonna get this out here. We're gonna make it. Gonna make it. Let me grab a file in the repository. I feel like I got like 1 second left, but we're gonna do it. We're gonna copy. We're gonna do a vim of, we're gonna call this OVA unstig. This is what the actual pipeline was supposed to do for me. It set all this up. See how cumbersome this is. Yeah, sure. Come on. All right, under the gun. Can you do it? I need the Rocky music. Where's my theme music at? All right, cool. Boom, boom. All right. Oh, so here we go. All right, so what happens is this. I didn't want to grab this one, but it's okay. We can explain this real quick. So basically, you have a variable. The default for Packer is vagrant to install. You're gonna make an image of this size of 90 gigs. You're gonna use this ISO right here, and this ISO is actually sitting in the S3 bucket. And then once we do this, I have different. So I have a format type here, a QCal, that I can use. But remember, when you're in AWS, you have to use the machine image for that format image for that particular cloud. If you're in VMware, 9 times out of 10, you can use QCal and then convert it to an OVA. And then you also have different formats inside of Packer for GCP. So let's look at that real quick so you know what I'm talking about. Packer, where you search is Packer format. Let's do GCP. This is fine. This will give you a good example. So here they talk about type Google compute, and then they run through and give you an example of what you can do basically with your commands. So everything that you can do with your G-Cloud commands, you can do here. So here we go, builders, type, source image. Remember we talked about that source image earlier. You create that, and then the username, Packer, and then so forth and so on. So here I'm doing this for a QCal. And these right here are basically environment variables. I mean, they're environment variables local to the actual file. So these variables up here, that means they're local in this file. So user disk size is going to reference here. You're going to go through, create everything here. You're going to create all this. And then down here, this is where the meat and potatoes happen at. This is the fun stuff. So this is stuff that you can create. So in here, I can create, I can move files over that are local to, say, my actual bare metal machine into my Packer instance. I can move RPMs that are local to my machine inside of that. I can use Ansible playbooks down here that are local. And so if I want to do an install of, say, I wrote a playbook out that actually pulls down stuff from, say, a Nexus repository or what have you, I can move that over and do whatever I want to from there. So this is what's cool about Packer, is because now you can take what you want your machine images to look like, say on AWS, say what you want your containers to look like, what security concerns that you may have, you can cover that using Packer and then go from there. So that's what we're doing now. So if we want to open up for questions, I know we're out of time, so let's get to the questions because I know we got some.